Welcome back to Site Unreliability Engineering. In this episode, we'll go down into a little bit more detail of how to actually get better observability, specifically using instrumentation. With instrumentation, we want to measure events in code in software. Instrumentation is really useful because, as we know from our previous discussion, you can use instrumentation to emit the three pillars of observability: metrics, logs, and traces. Instrumentation can be done on its own and done in different ways. One of the most common is part of a white box monitoring solution. As we learned in our last episode, we have the ability to actually see inside the software and understand something about its internal state. It's the combination of instrumentation and white box monitoring that we actually know what's going on when a system's doing work and responding to something like a customer request. It's sometimes useful to go through a simple example to understand what actually to instrument in the first place. At a bare minimum, it's important to capture key events that actually impact customers. To return to our example with immutable cat photos on the blockchain, we consider a couple different key events. First of all, we know that certain people interact with the application in fairly predictable ways. They might be ordering cat photos or trading cat photos for other cat photos. We want to capture and instrument those key events because they know they're such a critical part of how our software works and how, more importantly, customers actually interact with that software in the first place. For most web-based applications, there are certain transactions that happen frequently and are also worth instrumenting. Oftentimes, this can be done automatically. For example, for our cat application, if we have the ability to order an immutable cat photo off the blockchain, that is typically going to be implemented as a web transaction. We can capture that automatically by doing some library-level instrumentation. It's important to prioritize instrumenting those key transactions that help us understand how people are actually interacting with the application in the first place. For instrumentation that captures different events, are you able to understand what happened before and after that event? In particular, it's that connection between all of the different relationships that allow you to build really interesting traces. Traces, of course, are really useful for finding and understanding bottlenecks and troubleshooting highly distributed architectures. Other than relationships, the other important thing to have around instrumented events is context. In other words, what was happening around that event? With context, you can ask questions like, what team was involved in deploying that code to production? Getting to a better understanding of where that event that you captured through instrumentation actually took place. It's the combination of relationships and context that give you additional information to better understand what was captured from instrumentation in the first place. All this work into instrumenting and getting better observability has an aspirational goal in sight. And that's that using this better understanding of these systems and understanding the work they actually do, you can make them better over time through better design. Kind of like becoming an expert whack-a-mole player, but instead with distributed complex systems. As you get better over time, you're able to quickly react to failures, and you're able to identify when the mole might appear in the first place. Unfortunately, this is a process that takes time. There's really no easy button to become an expert at operating distributed systems. When we consider all the things that can go wrong, the complexity of the components, and all the different interdependencies and different contexts you need to understand, it's a slow, gradual process. But fortunately, good data, especially from instrumentation, can help us become better experts on how our systems are actually behaving in the first place. It's a combination of instrumentation and using that to increase the observability of our systems we can use to actually become better domain experts of the things we actually operate and build in the first place. In our next episode, we're actually going to try and put some of these ideas in practice. See you next time.